Welcome to Chemistry Class 12. Today we're diving into the concept of concentration in solutions. Have you ever wondered how much sugar is actually dissolved in your cup of tea or how much salt is present in seawater? That's where the idea of concentration comes in. Concentration simply tells us how much solute is dissolved in a given amount of solvent or solution. Understanding this is crucial for chemists, pharmacists, and even cooks. Throughout this video, we'll explore various ways to express concentration, making it easier for you to analyze and prepare solutions accurately. Concentration isn't just a chemistry term, it's a practical concept that affects everyday life. For instance, the effectiveness of medicines, the taste of food, and even the safety of drinking water all depend on the concentration of substances dissolved in them. In laboratories, precise concentrations are essential for successful experiments and accurate results. That's why chemists have developed several methods to express concentration, each suited for different situations. Let's start by looking at the most common methods used in chemistry. One of the simplest ways to express concentration is by using mass percentage, often written as percent weight by weight or percent WW. This method tells us what fraction of the total mass of a solution is made up by the solute. For example, if you dissolve 10 grams of salt in 90 grams of water, the total mass of the solution is 100 grams. The mass percentage of salt would then be 10%. This method is especially useful when both solute and solvent are solids or when dealing with concentrated solutions. See how to calculate mass percentage in practice. Suppose you have a solution containing 5 grams of sugar dissolved in 95 grams of water. The total mass of the solution is 100 grams. To find the mass percentage, divide the mass of sugar by the total mass of the solution and multiply by 100. That gives you a 5% sugar solution. This straightforward calculation helps in preparing solutions with precise concentrations, which is important in both laboratory and industrial settings. Another common way to express concentration is volume percentage, or percent volume by volume percent VV. This method is especially useful when both solute and solvent are liquids. For example, if you mix 30 milliliters of ethanol with 70 milliliters of water, the total volume is 100 milliliters. The volume percentage of ethanol is 30%. This approach is widely used in the beverage industry, pharmaceuticals, and chemical manufacturing. Let's work through a quick example. Imagine you have 20 milliliters of acetic acid mixed with 80 milliliters of water, making a total of 100 milliliters of solution. To find the volume percentage of acetic acid, divide 20 by 100 and multiply by 100. The result is a 20% VV solution. This calculation is particularly important in preparing laboratory reagents and commercial products where precise liquid ratios are required. Sometimes we need to express concentration as mass by volume percentage, or percent WV. This method is commonly used in medical and pharmaceutical solutions. It tells us how many grams of solute are present in 100 milliliters of solution. For example, an oral rehydration solution, ORS, might contain 3.5 grams of sodium chloride dissolved in 100 milliliters of water. This makes it easy to prepare and administer solutions with the correct dosage. Let's look at a real-world example. An ORS solution used to treat dehydration contains 3.5 grams of sodium chloride in 100 milliliters of water. This is written as a 3.5% WV solution. Such precise measurements are vital in healthcare to ensure patients receive the correct amount of electrolytes. This method is also used in food science and laboratory preparation. Moving on to a more scientific method, we have the mole fraction, represented by the Greek letter chi. Mole fraction is the ratio of the number of moles of a component to the total number of moles in the solution. It's a dimensionless quantity, meaning it has no units. This method is especially useful in physical chemistry and when dealing with gases or mixtures where the number of particles is important. To calculate the mole fraction, you need to know the number of moles of both the solute and the solvent. For example, if you have 2 moles of solute and 8 moles of solvent, the total number of moles is 10. The mole fraction of the solute is 2 divided by 10, which equals 0.2. This method is particularly useful in thermodynamics and colligative property calculations. Molarity is one of the most widely used ways to express concentration in chemistry. It is defined as the number of moles of solute present in 1 liter of solution. The unit for molarity is moles per liter, often written as m. This method is especially useful in titrations, chemical reactions, and when preparing standard solutions in the laboratory. To calculate molarity, divide the number of moles of solute by the volume of the solution in liters. For example, if you dissolve 1 mole of sodium chloride in enough water to make 1 liter of solution, the molarity is 1 m. This calculation is fundamental in chemistry labs, especially when precise concentrations are needed for reactions and analyses. Molality is another important way to express concentration. It is defined as the number of moles of solute per kilogram of solvent. The unit for molality is moles per kilogram, written as m. Unlike molarity, molality does not depend on the volume of the solution, making it especially useful when temperature changes are involved. Find the molality of a solution. Divide the number of moles of solute by the mass of the solvent in kilograms. For example, if you dissolve 0.5 moles of glucose in 1 kilogram of water, the molality is 0.5 m. This method is particularly useful in studying properties like boiling point elevation and freezing point depression, which depend on the number of particles in the solvent. Normality is a concentration unit used mainly in titration experiments. It is defined as the number of gram equivalents of solute per liter of solution. The unit for normality is, and this method is particularly important in acid-base and redox titrations, where the reacting capacity of the solute matters more than just the number of moles. calculate normality, divide the number of gram equivalents of solute by the volume of the solution in liters. For example, if you have 1 equivalent of hydrochloric acid in 1 liter of solution, the normality is 1, and this calculation is essential for titration experiments, especially in analytical chemistry. Each method of expressing concentration has its own advantages and is suited for specific situations. Mass percentage is great for solid mixtures, volume percentage for liquid mixtures, and mass by volume for medical solutions. Molarity and normality are essential in laboratory chemistry, while molality is preferred when temperature changes are involved. Understanding when to use each unit is key to accurate solution preparation. It's important to note that some concentration units are affected by temperature changes. For example, molarity depends on the volume of the solution, which can expand or contract with temperature. On the other hand, molality is based on mass, which doesn't change with temperature. This makes molality a better choice for experiments involving temperature variations. In the medical field, expressing concentration accurately is vital. Solutions like saline, glucose, and ORS must be prepared with precise concentrations to ensure patient safety and effectiveness. Pharmacists and healthcare professionals rely on mass by volume and molarity to prepare and administer these solutions correctly. Industries such as food processing, chemical manufacturing, and water treatment also depend on accurate concentration measurements. For example, the concentration of preservatives in food or chemicals in industrial processes must be controlled to ensure quality and safety. Here, mass percentage and volume percentage are commonly used. In research laboratories, scientists use various concentration units depending on the experiment. Molarity is often used in chemical reactions, while mole fraction is important in physical chemistry studies. Accurate concentration measurements are essential for reproducible and reliable results. Selecting the appropriate unit for expressing concentration depends on the nature of the solute and solvent, the purpose of the solution, and the conditions under which it will be used. For example, use mass percentage for solid mixtures, volume percentage for liquids, and molality when temperature changes are expected. Let's quickly recap the key formulas for expressing concentration. Mass percentage is mass of solute divided by mass of solution times 100. Volume percentage is volume of solute divided by volume of solution times 100. Mass by volume is grams of solute per 100 milliliters of solution. Molarity is moles of solute per liter of solution. Molality is moles per kilogram of solvent, and normality is equivalents per liter of solution. When working with concentrations, it's easy to mix up units or forget to convert measurements. Always double-check whether you're using mass, volume, or moles and ensure your units are consistent. Pay special attention to temperature effects when using molarity and always use accurate measuring tools for precise results. To achieve accurate concentrations, use calibrated equipment, measure carefully, and follow standard procedures. Always dissolve the solute completely and mix thoroughly. If you're preparing solutions for experiments, label them clearly and record all calculations for future reference. Safety is paramount when preparing and handling chemical solutions. Always wear appropriate protective gear such as gloves and goggles, work in a well-ventilated area, and be cautious when handling concentrated acids or bases. Dispose of chemical waste properly and follow your lab's safety protocols. Concentration isn't just for the lab, it's all around us. From the strength of your morning coffee to the amount of chlorine in a swimming pool, concentration plays a role in many everyday activities. Understanding how to express and calculate concentration helps you make sense of the world and make informed decisions. Environmental scientists use concentration measurements to monitor pollution levels in air, water, and soil. Accurate data helps protect ecosystems and public health. For example, the concentration of lead in drinking water must be kept below safe limits to prevent health problems. Food scientists measure concentrations of ingredients, additives, and nutrients to ensure quality and safety. For instance, the amount of sugar in soft drinks or preservatives in packaged foods is carefully controlled using concentration calculations. Water treatment facilities rely on concentration measurements to purify drinking water. Chemicals like chlorine are added in precise amounts to kill bacteria and make water safe. Monitoring concentration ensures that water meets health standards and is safe for consumption. Farmers use concentration calculations to mix fertilizers and pesticides correctly. Applying the right concentration ensures healthy crops and minimizes environmental impact. Over or under concentration can lead to poor yields or environmental harm. Pharmaceutical companies must prepare drugs with precise concentrations to ensure safety and effectiveness. Even small errors can have serious consequences. That's why strict protocols and quality control measures are in place to guarantee accurate concentrations in medicines. Beverage manufacturers use concentration calculations to create consistent flavors and strengths. Whether it's the caffeine in coffee or the alcohol in wine, precise concentrations ensure that every bottle or cup tastes the same and meets regulatory standards. Cleaning products like disinfectants and detergents are formulated with specific concentrations of active ingredients. Too much or too little can affect their effectiveness. Manufacturers use concentration calculations to ensure products work as intended and are safe to use. Cosmetic products such as creams and lotions require precise concentrations of active ingredients to be both effective and safe. Chemists carefully measure and mix these ingredients to create products that deliver the promised results without causing harm. Perfume makers use concentration to blend essential oils and alcohol, creating fragrances with different strengths. The concentration of aromatic compounds determines whether a scent is classified as eau de toilette, eau de parfum, or perfume. Paint manufacturers control the concentration of pigments and binders to achieve the desired color and consistency. Accurate concentration ensures that paints cover surfaces evenly and last longer, providing both aesthetic and protective benefits. Battery manufacturers use concentration calculations to prepare electrolyte solutions with the right strength. The performance and safety of batteries depend on having the correct concentration of chemicals inside. Pool maintenance involves monitoring the concentration of chlorine and other chemicals to keep water clean and safe. Too little chlorine can lead to bacteria growth, while too much can cause skin irritation. Regular testing ensures the right balance. Brewers carefully control the concentration of sugars, hops, and yeast to produce beers with consistent flavor and alcohol content. Accurate measurements are key to achieving the desired taste and quality in every batch. Perfume makers blend essential oils and solvents in precise concentrations to create unique fragrances. The concentration of aromatic compounds affects the scent's strength and longevity, making measurement accuracy crucial. Photographers use chemical solutions with specific concentrations to develop film and prints. The right concentration ensures clear images and proper development, highlighting the importance of accurate measurements even in creative fields. Textile manufacturers use concentration calculations to dye fabrics evenly and achieve consistent colors. The amount of dye and chemicals must be carefully measured to produce high-quality textiles that meet industry standards. Laboratory analysts use concentration measurements to determine the composition of unknown samples. Whether testing water quality or analyzing blood, accurate concentration calculations are essential for reliable results. Summary: expressing the concentration of solutions is a fundamental skill in chemistry with countless real-world applications. From medicine to industry, food to environmental science, understanding and calculating concentration ensures safety, quality, and effectiveness. Remember the different units, their formulas, and when to use each. With this knowledge, you're well equipped to tackle any chemistry challenge involving solution.